Machinex and UPM MRF, the international papermaker, have combined their know-how to build today's most modern recycling material facility. The papermaker made the decision to manage a recycling facility because it wanted to ensure a long-term supply of raw materials from old newspapers and magazines. They wanted to make sure that this material would be of superior quality. The industrial complex of UPM receives 640,000 tons of recycled fibers per year, 20% coming from the new material recycling facility. Located in Shotton in the United Kingdom, the material recycling facility is next to UPM's paper mill in order to provide it with recovered fibers. Let's see in detail the recovery process of recycling materials. Materials sent to the tipping floor are loaded into a feeder. The latter is equipped with a drum feeder which allows for a regular supply of the system. It offers a retention time and a constant flow of materials to process. Pre-sorting in the enclosure is done by a team of sorters. They remove the rejects such as big metal objects, electronic equipment, and any objects that could damage the equipment. A hood system extracts by suction plastic bags and wraps that are then manually removed. They are directly sent to a baler. Bags containing materials are dropped down a chute. They are then redirected to a bag opener, which removes their contents. The contents fall onto a conveyor which brings them back with the other materials at the start of the sorting process. Once the undesired materials are removed, the rest is sent to an OCC screen in order to recover cardboards. The cardboards bounce on the parts in motion while fibers and containers fall between the discs. Glass containers break and the debris falls with the fines between the discs of the first level onto a glass breaker screen. Almost 80% of the glass will be recovered at this stage. Then, a sorter verifies the cardboard quality in order to ensure the purity of the material. The rest of the material, including newspapers, mixed papers, cartons, and containers, is then sent to a more refined sorting process. Two sorting lines separate fines as well as flat and hollow objects. An assembly of 3 disc screens was added in order to meet the high volume of materials entering the system. A first level of sieving installed on top of the other 2 is used to remove fine particles of 4 inches or less. The rest of the glass is sent to finishing. Containers fall between the discs of the 2 superimposed Mach 1 separators, while fibers are thrown upward. Fibers coming out of the 4 Mach 1 separators are sent through an optical sorting unit. The latter includes 4 units that separate cartons from newspapers. A 5th optical sorting unit receives the ejections of the first 4 to retrieve newspapers not detected by the previous optical sorting process. Quality control is then made by sorters to remove cartons, containers, plastic wraps, and rejects left by mechanical and optical sorting. We end up with materials of unsurpassed quality with a purity rate of 98%, a prerequisite condition of the client. Newspapers and magazines finally go through an optical scanner to make sure that the desired purity is obtained. The recovered material is directly sent to the paper mill on a 440-foot-long conveyor. At the mill, the raw material is ready to be recycled into newspaper. The next stage consists in finalizing the separation of the remaining fibers from containers. Once cardboards, newspapers, and magazines are removed, the rest of the material is sent through two 3D finishing disc screens to separate the material into three flows. Containers roll off to the side. Mixed papers stick to the rubber discs to go up the separator, and the rest of the glass falls between the discs right at the beginning. Mixed papers coming from the finishing separator are sent through an optical unit equipped with two ejections which separate containers and cardboards from mixed papers. The flow of mixed papers is moved toward a disc screen to recover a maximum of the remaining newspapers and magazines. Manual quality control is finally done for the mixed paper to make sure that the desired quality is obtained. Materials that rolled off the sides of the 3D finishing disc screens are moved to the automated sorting line for containers. The line passes under a flat and light separator in order to remove papers and plastic wraps from the flow of containers. A manual sorting station is then used to maximize the recovery of newspapers, magazines, and phone books. The flow of containers continues on a conveyor over which is installed a magnetic separator that picks up ferrous metals such as steel containers. The containers are then sent to another disc screen which transfers the containers of 6 inches or less to an eddy current separator. The electromagnetic current ejects aluminum cans from the line and separates them from the rest of the containers. Aluminum cans then go through a quality control station to make sure that the desired purity is obtained. Containers are moved through a series of optical sorting units on 3 levels which separates plastics into different categories. A vibrating feeder uniformly spreads the materials in order to optimize optical scanning. The flow of containers passes through the first optical sorting unit which ejects the PET. Other plastics fall onto the second unit which ejects the HDPE. The third unit ejects mixed plastics. PET and HDPE are sent through a fourth optical unit which is divided in two. The two plastic types are sorted according to their color, transparent and colored. Transparent PET and HDPE go to quality control, and the colored ones are sent to their respective stocking area. Quality control is finally done on the line of mixed plastics in order to eliminate the containers. Manual sorting is also done on the line of rejects to recover the rest of the recyclable materials. Fines, mostly glass, obtained from the previous stages pass under a magnet to remove ferrous materials and then are sent to a glass cleanup system. At this stage, an air separator extracts light particles such as paper fragments and glass dust by suction. Oversized particles are rejected. This system, developed by Machinex, is designed to remove from the glass all other particles in order to obtain a final product of high quality. With this process, it is also possible to sort glass fragments in up to 3 categories according to their size. Glass is finally moved to a container which will be sent to a recycling facility. Once sorted by category, all other materials end up in automated storing areas with mobile flooring. Developed by Machinex, the Mac Motion Floor moves the material to the baler conveyor to be put into bales. 2 balers are operated by personnel. A first horizontal baler is used for containers and fibers. Developed by Machinex, this single-ram high-density extrusion baler is one of the most innovative. It combines the pre-baling and shearing stages. The second baler is used to bundle plastic bags and wraps. The bales are sent to recycling facilities to be transformed into new consumer goods. Because fiber supply is of crucial importance to the UPM paper mill, Machinex has equipped the system with 2 independent fiber sorting lines. Therefore, when maintenance is required on one of the lines, production can continue and keep feeding the mill using the second line. This concept can also be applied to the container sorting line, should it require maintenance. The fiber line can still operate and feed the paper mill. The system developed by Machinex proves that it is possible to obtain unsurpassed performance rates with high tonnage and minimum personnel. At Machinex, our engineers not only design systems for the customer, they design them with the customer.